Like all theories, the plate tectonics theory is based on findings that were replicated, that were supported by plenty of data and agreed upon, but not understood. These findings were not visibly connected, and sometimes they were connected. But scientists at the time didn't have an answer about why we have these findings. Theories, they start as a hypothesis explaining those proven findings. Once that hypothesis is supported by sufficient data, that hypothesis becomes a theory. If the hypothesis was just describing a natural phenomenon, it would become a law. But in this case, in the case of a theory, since it is explaining previously proven findings, then it becomes a theory. And that's why we call it the plate tectonics theory. Now, what are these findings for the plate tectonics theory? What brought the theory to fruition? Before the plate tectonic theory came about, scientists have observed continental drift, which is the large-scale motion of continents relative to each other. This motion happens over long periods of time. Connected to that is the fact that continents look like part of a jigsaw puzzle. These were findings that were known before. Now there is another finding. Distant continents, like the western side of Africa and North America and South America. Parts of Western Africa has fossils. When you look at the layers of rocks, you find fossils that are identical to fossils in North America. Another part of Western Africa have fossils that are the same as fossil records in South America. That also indicates that these continents were close to each other at some time. Moreover, when we started using submarines, we found that actually there are mid-ocean ridges, like what you see here, as plates move apart, resulting in what we call seafloor spreading. Now, wherever we have seafloor spreading, we are going to have a new crust forming below. Moreover, scientists were puzzled, why don't we have mountains, volcanoes, and earthquakes spread out evenly throughout the Earth? They actually occur around plate boundaries in specific places. Now we know that they are caused by plate tectonics, but before that we didn't know. Now there are some exceptions to this rule here, like volcanic activities in Hawaii and the Yellowstone Park. They are not along plate boundaries, but the others are along plate boundaries. These are due to what we call hot zones. If you'd like a list of the plates that we know of, you can find a list here. Look at the examples of things that are observed, that were known. Like here, we have two plates moving apart. This is actually in Iceland. This is over land. These are the Himalayas mountains. These are the results. This is near where the Andreas Fault is, the results of plates rubbing against each other. Now, all these findings are what helped scientists come up with the plate tectonics theory.